Hey, if you were not here on Monday, February 28th, then I'm going to go over what we were working on so that you can catch up or so that you can complete the work that we were doing and understand what we're going to do for the next couple of weeks. So to begin with, we had this paper here, which is based on the story of the tortoise and the hare. Okay, it says, once upon a time, there was a hare who was boasting how he could run faster than anyone else and was forever teasing the tortoise for his slowness. Then one day, the irritated tortoise answered back, "Who do you think you are? There's no denying that you're fast, but even you can be beaten." The hare squealed with laughter. A course was planned, and the next day they stood at the starting line. The graph below shows the data table of the two contestants. We're going to make a graph of the data to see what happened in the story. So first part of it is something that we have done before that you are familiar with, and that's dealing with the distance and the time. We're going to use this distance and time, that's right here, to plot the graph of movement at the bottom here. Okay, so we're going to start with the hare, and I am going to use the red, but when you're marking on here, it says that you're going to use a dot. Okay, so to start with, we have that the hare, after half an hour, went 1 mile. So that 0.5 hour is half an hour, which means we have to go halfway between 0 and 1. This is where the 0.5 hour will be. And we have to go up to the 1 mile point. And that's where we're going to draw the first point. So this distance is measured in miles. Okay, so that's our first point. Next, our second point is at 2 miles and 1 hour. So again, I'm going to come across the bottom to 1 hour and go up to 2 miles. I'll plot my next point there. Okay, that's that one. Then our next point is 3 miles, 3 hours. I'm going to go across to the 3 hours, up to the 3 miles, and draw my next point. That's that one. Then our next one is 4 miles in 8 hours. So I'm going to go across to the 4 hours, up to the, I'm going to go across to the 8 hours, which is this line right here, and then up to the 4 hours to make my next dot. Plot my next point. That's that one. Then our last one is 5 miles in 12 hours. So I'm going to go across to the 12 hours and then up to the 5 miles. This is actually the finish line, which means the hare finished the race in 12 hours. At this point, I'm going to connect all the dots to make our line graph. And remember that when you're doing a graph, it always starts at the origin. So our line starts here, and I'm just going to connect these dots. Just like that. Okay, so we've got our line to show that the hare started off at this pace. We can see a curve, so we can see a change of motion. Now, the part that's new is the part where we are now looking at calculating speed. Okay, speed is now a new subject that we're going to get into. And for calculating speed, we have a formula that is very similar to the formula of calculating density. When we calculate density, we're doing distance. With calculating density, we do mass divided by volume. So that's a measurement divided by another measurement. Well, when we do speed, it's the same kind of thing. Speed equals the measurement of distance divided by the measurement of time. So we are going to be working on this right here to calculate the speed of the hare. I'm also going to write it using this division symbol of distance divided by time equals speed. I need you to copy those down on your paper so that you can remember what this formula is. We're going to be using it for the next couple weeks. So let's look at this division. They've actually already done the first one for us. On the first one, it shows the distance is 1 mile, so they have the 1 here, divided by the time, which is 0.5 hours. So they got 0.5 here. So we have 1 divided by 0.5. Now remember, when you have a decimal over here, we've got to move the decimal once in this position, but that means we also have to move this decimal over once. When we move that decimal over once, we can now put a 0 and bring the decimal all the way up to the top. So now 5 goes into 10 2 times, which is how we get this answer of 2. Now, just like when we are calculating density, when we calculate density, we have to put the letters at the end of it to show what it represents. In density, we put grams per centimeters cubed. Well, in speed, we're going to put miles per hour. And I really want you using the slash instead of the P, because the slash is actually an operational sign for division. P is not. All right, so when we do this, I'm going to have you doing the slash. So let's do our next one. Again, we have distance divided by time. So our distance of 2 divided by our time of 1 hour. I'm going to go ahead and divide that. This is a very easy division problem. 1 goes into 2, 2 times. So our answer is 2 miles per hour. Okay. So our next one, distance divided by time. Our distance is 3 miles. Our time is 3 hours. When we divide this, again, this should be an easy one. We get 1 mile per hour. Okay. Then our next one, distance divided by time. We have our distance of 4 miles, our time of 8 hours. Okay. Now notice, we cannot just immediately start dividing. We have to actually provide a decimal so that then we can get a 0 behind it. So now 8 goes into 40 5 times. Our distance is 0.5 miles per hour. And then our last one, we have our distance of 5 miles divided by our time of 12 hours. And just like the last one, when we write this out, we cannot immediately start dividing. We have to put a decimal so that we can then have a 0 at the end. 12 goes into 50 4 times. Multiply those to get 48. When we subtract, we get 2. We're going to continue by adding another 0. And 12 goes into 20 1 time. So when I subtract these, we get 8. We have to continue on by putting another 0. And then 12 goes into 80 6 times. At this point, we can actually stop because this now allows us to round to the hundredths place, which is what I always ask you to do. When we round this to the hundredths place, we now get 0.42. So we are now at 0.42 miles per hour. Okay, so we've now calculated the speed of the hare, and we can now easily see that he started off fast at 2 miles per hour, 2 miles per hour. Then he started slowing down to only 1 mile per hour, and then he continued slowing down to 0.5 miles per hour and then 0.42 miles per hour. So mathematically, we can see what this graph is showing us. Okay. So now that covers the hare. Let's go into what the tortoise does. Okay. The tortoise is on this side. And once again, we already know the distance. So we're going to record the distance onto the graph. We're going to start with our first distance of 1 mile and 2 hours. So I'm going to go across to 2 hours, go up to 1 mile, and this time it says we're going to draw a triangle. So I'm going to draw my triangle for 1 mile and 2 hours. Next one, we have 2 miles and 4 hours. So I'm going to go across to 4 hours, up to 2 miles, and draw my next triangle. And then our next one is 3 miles in 6 hours. going across to 6 hours, up to 3 miles. You have that one. And then 4 miles in 8 hours. Go across to 8 hours, up to 4 miles. And you'll notice at this point, they actually overlap. It's okay for them to overlap. That happens sometimes. That just means the tortoise is now past the hare. Then our last one, 5 miles in 10 hours. I'm going to go across to the 10 hours, up to the 5-mile mark. And again, the 5-mile mark is where our finish line is. And so this shows us that the tortoise finished the race in 10 hours. Once again, we have to connect these with the lines starting at the origin. And what you should be noticing is that we have a very straight line for the tortoise. I told you last week that when it's a very straight diagonal line, it means it's a constant pace. So that's now what we're going to show over here while we calculate the speed. Now for calculating the speed, once again, they already did the first one for us. We have distance divided by time. So 1 mile divided by 2 hours. They've set it up here. We have to add the decimal to be able to do this. Now 2 goes into 10 5 times. That's how they got the 0.5 miles per hour. Okay, so our next one, we're going to do the distance of 2 miles divided by the time of 4 hours. 2 divided by 4, you have to add a decimal. Then we can add a 0. And now when we divide, we get 0.5 miles per hour. Then we're going to do our next one. Distance of 3 miles divided by time of 6 hours. Once again, we have to add a decimal. So now when we divide, you're once again getting the same answer of 0.5 miles per hour. You should be able to see a pattern here. Again, we have distance of 4 miles divided by time of 8 hours. So 4 divided by 8. We got to add our 0 with a decimal. And once again, we get 0.5 miles per hour. And then our last one, 5 miles in 10 hours. So distance divided by time. Again, we have to add our decimal and our 0. And this goes in 0.5 times. So 0.5 miles per hour. So the idea here is that this is a very consistent time, just like this is showing a very consistent pace. Okay, so we can now see that the hare finished the race in 10 hours. I'm sorry, the tortoise finished the race in 10 hours. The hare finished the race in 12 hours. So the tortoise won this race. You're now going to take this information right here for the speed, and you're going to turn your paper over to graph it again using speed instead of distance. Okay, so right here, we now need to look at the speed and the time to graph the tortoise and the hare. Okay, so starting with the hare, the time is 0.5 hours, which is right between 0 and 1. The speed is 2 miles per hour. So we're going to go from 0.5 up to 2 miles per hour to draw our first point. Next, we have 1 hour. So we're now on this line right here. And the speed of 2 miles per hour. So where 1 meets 2 miles per hour. We've got our next dot. Then we have 3 hours. So at the 3-hour mark right here, it's at 1 mile per hour. So we're finding where 3 meets 1 mile per hour, and that's our next mark. Our next one is 8 hours. I'm going to go across the 8 hours right here. was 0.5 miles per hour. So right here, we have 8 hours. 0.5 is actually already a line for us, so we can draw our dot right here, plot our next point. And then our last one at 12 hours was actually going 0.42 miles per hour. So this one we actually need to go right below that halfway mark. Okay, so now once again, we connect it from the origin. Just draw the lines. And the speed graph is now showing us that the hare started off fast and then slowed down. Okay, we're going to do the same kind of thing for the tortoise. The tortoise's time starts at 2 hours and the speed is 0.5 miles per hour. Okay, so at 2 hours down here, we're going to go up to 0.5 miles per hour and draw our triangle. Our next one is 4 hours for time and 0.5 miles per hour. Draw our next triangle. Our next one is 6 hours of time at 0.5 miles per hour. So our 6 makes half. Then we're 8 hours meets 0.5 miles per hour. So 8, 0.5. Once again, they overlap. Then we have 10 at 0.5, and this is where he wins. And draw those lines. Make sure you answer the 2 questions at the bottom here as well. Okay.